heat of formation and how to find delta H of a reaction using heat of formation. That is what we'll focus on in this video. What is heat of formation? Enthalpy, standard enthalpy of formation. The standard enthalpy of formation, which is also given by delta H naught F, is the enthalpy of formation of 1 mole of a compound from its constituent elements in their standard state. Okay, so what is enthalpy of formation? If I'm interested in what is the delta H naught F of any compound, then the heat that is involved in formation of 1 mole of that compound from its constituent elements in their elemental form and at their standard state. Okay, for example, if I'm interested in what is delta H naught F of water in its liquid form, I need to write a reaction for formation of water. The product should be water, 1 mole from its constituent elements, meaning it consists of hydrogen and oxygen. So water made from hydrogen and oxygen. The delta H for this reaction is going to be equal to delta H naught F of water. Okay, for example, if I'm interested in finding what is delta H naught F of CH4 gas, okay, I need to find the reaction where CH4 gas is my product from its element in elemental form. Carbon should be in its elemental form. How is carbon found in nature? As a solid, graphite specifically. Okay, that is the natural state of carbon. Plus hydrogen. I need hydrogen. How is hydrogen found in nature? Naturally, H2 gas. So this reaction should be balanced. How many carbon on the left side? 1. On the right side? 1. How many hydrogen on the left side? 2. How many hydrogen on the right side? 4. So I need a 2 right here. This is a balanced chemical equation. So delta H for this reaction is equal to delta H naught F of CH4. Any compound, as long as it is being formed from their element in elemental form, it is delta H for that reaction. Now what is standard? The standard state, when we are talking about standard enthalpy, the standard state of a substance is simply when the substance is most stable, which means it's at 25 degrees Celsius or 298 Kelvin and 1 atm. This is called the standard state in chemistry, just a definition. Okay, and every time we write standard state, we usually put this symbol called degree. Okay, we also call it naught. So delta H naught simply means I'm talking about this reaction being done at 25 degrees Celsius under 1 atmospheric pressure. Okay, I can also say delta E naught, which means this is the internal energy in standard state conditions. That's what this simply means. Okay, an important thing to remember here is that when we are talking about delta H naught F of any element in its standard state, it is going to be 0. For example, what does that mean? If I say what is the standard heat of formation of copper, okay, what is delta H naught F of formation of this? We are forming copper. Okay, there is no reaction to form copper. Copper is not a compound. Remember, delta H naught F is formation of a compound. This is already in its elemental form. So how do you find copper? You will find copper as a solid. Okay, so if you're trying to make copper and converting it into copper solid, this is not a reaction. Nothing new is happening here. So delta H naught for this reaction is going to be 0, which simply means whenever you're trying to find delta H naught F of any element in its natural state, standard state, meaning in its naturally existing state, it is always going to be 0. For example, what is standard heat of formation of iron solid? It is always going to be 0. If instead I say iron liquid, then it could be different, because iron naturally exists as a solid. So I will get solid iron and I will convert it into iron liquid. This delta H naught F will have a certain value, let's say X. But if I'm asking you what is the heat of formation of iron solid, directly We are not forming this from something else. This is not a reaction, so it is 0. This is how it naturally exists. Example, what is the heat of formation of hydrogen gas? Okay, hydrogen gas. This is how it naturally exists, right? So if you want to use hydrogen gas, you will get hydrogen gas in a natural form. So you're not forming something new. That is why heat of formation is 0. Heat of formation of fluorine, 0. Heat of formation of nitrogen gas, 0. Heat of formation of oxygen gas, 0. This is how they naturally exist. So just remember, if you're finding heat of formation of a naturally existing compound, it is 0. That is how it is found in nature. We are not forming it. This table shows you the delta H naught F heat of formation for multiple substances. Okay, for example, CO2 is this much, and you will see the unit is always per mole, which means for making 1 mole of a substance. So your reaction should be making only 1 mole of that substance. Okay, water in liquid form is this, in gaseous form is this, SO2 in gaseous form is this. Okay, so again, it should be the same compound, it should be 1 mole, and it should be in the correct physical state, solid, liquid, gas. Okay, how this is useful for us? Sometimes we can use delta H naught F to calculate heat of the reaction. How do we find it? The heat of reaction is going to be sum of delta H naught F of products minus sum of delta H naught F of reactants, which means if I have a reaction A plus B gives me C plus D, what would be delta H for reaction of this? It would be delta H naught F of product, which is D, plus delta H naught F of second product, which is C. So all my products sum minus reactant. Reactant is A, so delta H naught F of A plus delta H naught F of B. So sum of product minus reactant. Remember, it's always delta H naught of product minus reactant. Do not mess this up. Okay, it should be product minus reactant, not reverse. Now, when a reaction involves multiple moles of product and reactant, for example, let's say it's not 1, it's A moles of A, B moles of B, C moles of C, and D moles of D. How do I do this then? Then you just multiply this by your number of moles. So A, when it comes to D, it will be multiplied by number of moles. I'll multiply this by number of moles of C, this by number of moles of A, this by number of moles of B. You multiply and you include the number of moles. Okay, why? Because I am now using A moles of A, which means how much heat will be released? A times the heat. Okay, questions are very simple and very direct for this. For example, like this: calculate delta H naught reaction for complete combustion of 1 mole of C3H8 at 25 degrees Celsius, 180. Combustion of C3H8 1 mole, which is this reaction C3H8. The question is asking what is delta H naught for this reaction. Okay, and delta H naught F is given to you for all your reactants and products. Okay, how will we use this information? What delta H naught for this reaction is going to be sum of all my product minus reactant, right? So I have 3 CO2, which means it will be 3 times delta H naught F of CO2. My second product is water, which means it will be 4 times delta H naught F of water minus product reactants, this time C3H8. So delta H naught F of C3H8 times 1, because I only have 1 mole of this, plus 5 times delta H naught F of oxygen. Okay, now C3H8 is given to me, so I can plug that number here. Carbon dioxide is also given to me right here. Water is also given to me. C3H8 is also given to me. The question does not give me H naught F of oxygen. Okay, how can I do this? Delta H naught F of oxygen is going to be equal to 0. Okay, even though it's not given to you, you should know this. Why? Because oxygen is in its gaseous form, which is the elemental form of oxygen. So I'm not forming oxygen. Okay, if you write the reaction, it is oxygen gas being formed from oxygen gas. That is not a chemical reaction. Nothing is changing here, right? So this is what is heat of formation. Heat of formation is when you're forming a compound from its elemental form. Oxygen is not a compound, it is an element, right? So therefore delta H naught F, we are not forming it, so delta H naught F for this is also 0 kilojoules. Okay, so plug in the values, make sure you include the coefficients here. Okay, and that is it, that's your answer. Okay, so for example, right here I found delta H naught of products. We did this separately. Products, sum of delta H naught of reactants, and then you take the difference between the two. Product minus reactant. Okay, make sure you include the moles though. Okay, another example is like this. Calculate enthalpy change for the following equation. Okay, this is the equation. I need to find what is delta H of my reaction. Heat of formation is given to me. Butane is, it tells me it's 125.5. Tells me carbon monoxide is negative 110.5. Water is negative 285.8. So oxygen would be what? It will be 0 because oxygen is in its elemental form. It's not a compound. Okay. So what would be heat of the reaction? It will be 10 times water. You can write that down on your own. Okay. So I'm writing all the products plus 8 times delta H naught F of carbon monoxide minus reactant, which is 2 times delta H naught F of C4H10. Plug all of these in and get your answer. Oxygen is 0, so I did not include it.